Decision tree organizes a series of rules in the tree structure. It is one of the most practical methods for non-parametric supervised learning. Our goal in this video is to demonstrate how to create a decision tree that predicts the value of a target by learning decision rules inferred from the training data. Let's first have a look at some important terminology of decision tree. The root node is at the beginning of a tree. It represents the entire population being analyzed. Splitting is the process of dividing a node into subnodes. When a subnode can be split into further nodes, then it is called decision nodes. Leaf nodes are the nodes of a tree that have no further splitting nodes. When we remove subnodes of a decision node, this process is called pruning. This is the opposite process of splitting, which is used to prevent overfitting. Now let's demonstrate the process of creating a decision tree from data. First of all, let's inspect the dataset. In this example, there are two classes and two features, size and color, for the training data. We can construct some decision rules from the features. For example, here are two simple decision rules. The first is whether the size is greater or equal to 2, and the second is whether the color is yellow or not. In real application, there are usually a lot of decision rules we can choose from, so we need to find a way to choose the best decision rule to split the current node. Starting from the root node, we are going to iterate through all the decision rules and calculate the information gain of the current split. Calculating information gain is the centerpiece of this step. So what is information gain? Let's have a closer look at each group within a decision rule. The group is pure when all of its records belong to the same class. Here we use Gini impurity to measure how pure the current node is. When the group is pure, Gini impurity is 0. When the group is half and half mixed, Gini impurity is 0.5. For any decision split, a parent group is split into two child groups. The information gain of this split is the impurity of the parent group minus weighted average impurity of the child group. Once we calculate the information gain of each splitting decision rule, we now can select the decision rule which has the largest information gain to split the current node. Then we can split the child node recursively, and only considering decision rule never selected before in the current branch. We stop splitting if there are no decision rules left or the group impurity is 0. Sometimes pruning and early stop condition are used to prevent a large number of splits and overfitting. Now the decision tree can predict the probability of each class as the ratio of each class in the node. In this case, for the record with size greater or equal to 2 and color is yellow, there is a 50% chance the class record is a circle. So that is a brief demonstration of how to construct a decision tree from data. It has a lot of advantages like easy to interpret and straightforward for visualizations. However, it has a big disadvantage. Single decision tree models are prone to overfitting, especially when a tree is particularly steep. One way to combat this issue is by setting a max depth of the tree. This will limit the risk of overfitting, but this will be at the expense of increasing bias. Random forest is a good way to prevent overfitting without sacrificing bias. It is simply a collection of decision trees whose results are aggregated into one final result. It is a strong ensemble modeling technique and much more robust than a single decision tree. So in real-world application, people usually go directly into using random forest for modeling. I hope you like this video. Don't forget to subscribe to us and ring the notification bell and stay tuned.